we go back to our aluminum cyclic test data for our next example of hypothesis testing, this time for variance or standard deviations of a normal distribution. And so we're going to call this example HT 2.2, but we're really just extending HT 2.1. Right? And really the sort of general question is what can be said about variance. We had unknown mean, unknown variance for our data. And so we're going to set up this time a null hypothesis that's in regards to our true variance being equal to some value, with an alternative being, in this particular case that we're interested in, that the variance is larger than some specified value. And we'll get to some numbers here in a second, but let's just talk about what the test statistic is that we're going to look at. And just like when we did confidence intervals for variances, we're going to look at the quantity of n minus 1 times our sample variance divided by this threshold variance of interest to us. And our rule is going to be to reject our null hypothesis if our test statistic is larger than our critical value. Right now, this is a one-sided version. There's and one particular one-sided version that matches what our alternative hypothesis was. We turn this around if we're looking at the other end, and if you're looking at a two-sided, then we handle this in the similar way that we were dealing with before. Okay, we're going to let our threshold value be equal to a particular COV related value. That turns out to be, in this particular case, what we're interested in, that we're concerned about variances that are larger than a certain kind of value. So if we look at 30% as our COV, that means our standard deviation is 30% of the mean, and if that 30%, if that mean value that we were looking at before was 1300, even though we rejected that, we're going to continue on with that for this particular case. So 0.3 times 1300 is equal to 390. Now, I might have, if I were processing this in a little bit different way now that I've rejected that the true mean is equal to 1300 at the 5% significance level, I might have rerun that and done that with a different particular mean value, and then therefore a different sort of COV. But as just an illustration, this works out okay. So our variance then, that was just to get our threshold value for our standard deviation. Okay. So if you go and look up in your chi-square table, right, we're going to have to go first, of course, calculate here our test statistic. And so n minus 1 is 69. Our sample variance was 402 squared, and then divided now by our threshold value of 390 squared. And we do that real quick. 69 times 402 squared divided by 390, and 73.3 is our test statistic value. And if we look in our tables here, we'll see that for this single tail, right? So, oops, didn't write that down before. This is at the 5% significance level. And so and we have 69 degrees of freedom. Well, you'll find in that particular table that we've got 60 and we've got 70. It's real close to the 70, and you'll note that we could do a bounding if we wanted to. But this number is going out of the table. It's going to be about 95. That's far enough away here that we don't really have to be too concerned about this number is like about 83 if we're talking about this degrees of freedom being around 60. So we're still in the acceptance region, which means that our conclusion here is that we're going to fail to reject H naught, which is just another way of saying that we have no convincing evidence that H naught is false. And that's another way to say it. No convincing evidence that H naught is false at the 5% significance level. Right, and that's a little bit of a weak statement, right? I mean, but we have to be that way a little bit, because we don't want to say that the alternative is correct, right? It could be that, gee, the variance is less than this. So there's, you know, a little bit of a wishy-washy kind of thing going on here. We just don't have convincing evidence here that H naught is false, which is what we were, in some ways, that's the kind of thing that you're looking for is, hey, based upon this sample set, is there convincing evidence for a particular kind of conclusion, right? And of some note here, if we used 1400 for a number here, then our sample variance becomes 420 squared, and then the test statistic only gets smaller, right? So we have a fairly reasonable reason to believe that this is somewhere in the kind of ballpark, just based upon our sample that we have. Right, now, the other aspects to keep in mind is that with these, just like the others, there's some operating characteristic curves done in a slightly different non-dimensional way, but you'll see that in the text. And just like in the we saw also with the t-distribution, and that we can come up with the operating characteristic curves for those slightly different, because now they got the t-value in there, and we can come up with sample size and type 2 error probabilities, and you'll see that in the text as well.